An empirical formula is the simplest whole number ratio of atoms. The simplest whole number ratio of atoms. So you cannot have 1.5 or 1.3. It will always end up being a whole number. And a molecular formula is the exact whole number ratio of atoms. Is this an empirical formula, or is this a molecular formula? Can you reduce this? Yes. What's the reduced form? NO2. So NO2 is our empirical formula. N2O4 is our molecular formula. So you divided both subscripts by 2. Second example, C2H6. Can you reduce that? And what do you reduce it to? CH3. So this is your empirical formula. This is your molecular formula. How about the last one, H2O? Can you reduce that? Nope. So its empirical formula is the same. That is the lowest whole number ratio. So you take your percent composition and you figure out the empirical formula using these 4 steps. First step, assume a 100-gram sample. You have to write that out. Assume a 100-gram sample. We assume 100 grams because percents are per 100. So we have 79.9% carbon and 20.1% hydrogen. So if we assume a 100-gram sample, we have 79.9 grams of carbon and 20.1 grams of hydrogen. If we take the mass, divide it by the molar mass of carbon is 12.01. Molar mass of hydrogen is 1.01. We'll find the number of moles of each of our elements in our sample. It's okay. We've got that number of moles of carbon and that number of moles of hydrogen. Beautiful. So, we've done steps 1 and 2.
I thought that was like a double H. I was like, what is that?
What the heck? That's just plain magic. And I can't erase it because I've stopped recording. It won't let me. It's mole. Ah!
What are you up to?
I've had too much sugar today. Mole of H. Okay, so step 3 says divide all the moles by the smallest number to figure out the ratio. So which one of those 2 numbers is the smallest, carbons or hydrogens? Carbons, so divide both of them by 6.65278. So that, of course, is 1 carbon. Thank you. So 2.99 can get rounded to 3 because it's only 2/100ths away. So this is essentially 3 hydrogens. So our empirical formula is CH3. There's your empirical formula. 1 carbon for every 3 hydrogens.